Hi students, MCQ number 35. Three concentric metallic spherical shells of radii r, 2r and 3r are given charges q1, q2 and q3 respectively. It is found that the surface charge densities on the outer surfaces of the shells are equal. Then the ratio of the charges given to the shells, namely Q1 is to Q2 is to Q3 is to be determined. Very brilliant question. This has been asked several times in the IIT mains exam. Such an important numerical problem. Okay, what is the meaning of charge density? Charge density of the spherical shell is what? The total charge Q distributed on the outer surface divided by the total surface area 4 pi into r square. That is equal to sigma. So the moment we look at the question now, it will mislead to the wrong answer only. Here one concept is hidden, which is not shown anywhere, but in the diagram we have to understand. Yes, my dear students, you see now the inner shell, the first shell is having a radius r, that is the smallest. Then the middle one is having a radius 2r, twice the radius, and the third one is having a 3r. Okay, then what are the charges actually we are giving to the sphere respectively q1, q2 and q3? Look at the picture now. q1, say it is positive charge, for example. I have distributed the charge q1 on the outer surface of the first sphere. Understand? Okay. Now what will happen? This presence of the positive charges on the outer surface of the smaller sphere will induce equal amount of negative charges on the inner surface of the second sphere. Are you understanding? This is due to electrostatic induction. So you have to remember, children, this q1 coulomb of charge is positive on the outer surface of the first shell, and equal amount of negative charges will be induced. So I am showing here in between these positive charges that the inner surface will be induced with the same amount of negative charges. In addition to that, so this will induce, this negative charges will induce once again what? Positive charges on the outer surface of the second shell. Understand? Like this. So already we are giving q2 coulomb of charge for the outer surface of the second sphere, but additionally another q1 coulomb of positive charge due to electrostatic induction is added up. Clearly understand the concept. The positive charges on the outer surface of the smaller shell of radius r induces equal amount of negative charges on the interior of the second shell. This again induces q1 coulomb of positive charge on the exterior of the second shell. So though we are giving q2 coulomb of charge actually to the second shell, in addition how much charge is getting added up is q2 plus q1. This is very interesting and intelligent point to be understood. I hope now you must have understood. Okay. So now what is the actual charge present on the outer surface of the second shell? It is q1 plus q2, is it not? Okay. What kind of charge it is? Positive charge. This once again will induce an equal amount of charge on what? The interior of the third shell. Yes, sir. So q1 plus q2 coulomb is now what? A total charge present on the outer surface of the second shell. This will induce an equal amount of negative charge on the inner surface of the third shell. Okay, this is equal to what? How much? This negative charge, yes, how much it is? q2 plus q1. Okay, this will equally induce positive charges on the surface, outer surface of the third shell. So understanding is very important here. So In addition to that, we are giving how much charges actually to the third shell is Q3. Okay. So in addition to Q3, Q2 plus Q1. So Q2 plus Q1, the induced charge also gets added up. Yes, my dear students, now understand. Look at the picture once again. What is the radius of the first shell is R. What is the actual charge located on the outer surface of the first shell is Q1. Understand? Now, what is the radius of the second shell is 2R. What is the actual quantity of charge distributed on the outer surface of the second shell is now Q1 plus Q2. Similarly, the radius of the third shell is 3R. And now the actual amount of charge found on the outer surface of the last shell, that is bigger shell, is Q1 plus Q2 plus Q3. This idea is used here. I hope now you can continue this problem very simply. Okay. In a simple way, the surface charge density, see sigma. Sigma is equal to total charge divided by area. This is constant. So this is equal to constant for all the three spheres. Okay. What is Q for the first shell? That is Q1. Is it not? So Q1 divided by 4 pi into R square. R is the radius of the first shell. So Q1 divided by 4 pi R square must be equal to, what is the charge present on the outer surface of the second shell now? The net charge is Q1 plus Q2. So this is Q1 plus Q2 divided by 4 pi into 2R the whole square. Care should be taken because R2 is equal to twice the radius R. So 2R the whole square. And this is now equal to what? Q1 plus Q2 plus Q3. That is the charge present on the outer surface of the third shell, divided by its surface area is 4 pi into 3R the whole square. Okay. So now we can equate this. See here, Q1 by 4 pi R1 square. Okay. Q1 by 4 pi R square is equal to Q1 plus Q2 divided by, now this is 4 pi into 4R square. 4 pi into 4R square. So 4 into 4 is 16. So this is 16 pi R square. And this is now equal to Q1 plus Q2 plus Q3 divided by 3R whole square is how much? 9R square. 9 4s are 36. So this is 36 pi R square. So this all the three are equal to sigma, which is constant. Therefore, now I will take Q1 by 4 pi R square is equal to sigma. Therefore, what is Q1 is equal to 4 pi R square into sigma. This is our equation 1. Okay, this is Q1. Next, I will take the second step. Okay, this second one term, Q1 plus Q2 divided by. Okay, so Q1 plus Q2 divided by 16 pi R square is equal to sigma. So Q1 plus Q2 is equal to 16 pi R square. 16 pi R square into sigma. So this is equal to 4 into 4 pi R square into sigma. Okay. So Q1 plus Q2, left hand side is what? Q1 plus Q2 is equal to 4 into 4 pi R square sigma. But you see here 4 pi R square into sigma. 4 pi R square into sigma is nothing but what? Q1. It is also equal to Q1. Understand? So now I can write Q2 is equal to 4 into 4 pi R square. 4 into 4 pi R square, okay, into sigma minus Q1. So Q1 is equal to 4 into 4 pi r square into sigma minus 4 pi r square into sigma. So this is equal to 4 pi r square sigma. I will take it as common. So 4 pi r square into sigma into 4 minus 1. Okay, into 4 minus 1. So this is equal to 4 pi r square into, that is 3 into 4 pi r square into sigma. So this is our equation 2. So we have got an expression for Q2. Now the third term I am going to take Q1 plus Q2 plus Q3. Okay, so this is equal to or divided by, so this is divided by 36 pi r square, 36 pi r square. So this is equal to sigma, so Q1 plus Q2 plus Q3, and this is equal to 36 pi r square into sigma. Therefore, what is Q3 is equal to, therefore Q3 alone is equal to 36 pi r square sigma minus of Q1 plus Q2. Already we have found, is it not? Q1 plus Q2 is 4 into 4 pi r square, that is 16 pi r square into sigma, is it not? So minus Q1 plus Q2. So this is equal to 36 pi r square into sigma minus 16 pi r square into sigma, and this is equal to 20 pi r square into sigma, that is equal to 5 into 4 pi r square into sigma, and this is our equation 3. Now see, whichever method mathematical calculation you feel to do, you can do. Simply I am doing as a multiple of 4 pi r square into sigma. I am keeping it 4 pi r square always constant, understand, into sigma. So that the ratio only we have to find out. So what is Q1? Q1 is 1 into 4 pi r square sigma, and Q2 is 3 into 4 pi r square sigma, and Q3 is 5 into 4 pi r square into sigma. So that the constant is what? 4 pi r square into sigma, is it not? Therefore Q1 is to Q2 is to Q3 is equal to 1 is to 3 is to 5. You can keep as a multiples also. 12 pi r square sigma, 20 pi r square sigma, in any way you can do, but the ratio will be the same, is it not? So what is the ratio of Q1 is to Q2 is to Q3 is now equal to what? 1 is to 3 is to 5. Okay. So which is the right option? Option B. Okay. Therefore option B is the correct answer. So problem understanding only is very much important. Afterwards mathematical calculation still much shortcut also is available. But at the beginning level, always do systematically, take much time. While learning, you take much time. Understand? While executing in the examination hall, take less time. But do it successfully. I hope you must have understood well. Fine.